Hi, I'm Ray from the Friday Institute. This is the third video in our series from November 2020 covering E-rate data and analysis. Wanted to go over this dashboard about Wi-Fi, but just for context, let me go back to the last video. We talked about the total overall E-rate dashboard. This dashboard is really about the money and the funding and our success using the E-rate program mechanically, from processing and asking for money and getting it. This dashboard is from 2017. This was the third year of the Wi-Fi expansion program, so we were halfway through the, at the time, 5-year kind of experimental E-rate modernization thing where the FCC said they would pay $150 per student for Wi-Fi, technically internal connections. So it was Wi-Fi, firewall, switches, cabling, many other things. But we colloquially we refer to it as the Wi-Fi program because it was not internet outside of the school building. It was the stuff that stays inside the school building and connects the kids' devices to the internet. We basically downloaded a massive amount of data and did a lot of manipulation of that data in 2017 to help make sure that we were directionally headed the right way with the way we were spending money and our rules that were in place, and making sure we were being cost effective, equitable, and that the program was going to achieve what we wanted to. I'm happy to say that a year later, after this dashboard, we actually had the FCC chairman come to, I think it was Graham County High School in Alamance County, and meet with various elected folks and celebrate the idea that we had Wi-Fi in every classroom. And the data that we used to ascertain that is pretty much from the Digital Learning and Media Inventory from DPI, which is an annual technology survey that DPI conducts that is very important. And then the USAC, the Universal Services Administration Corporation data portal, which is technically how people apply for the FCC E-rate program. The links to all this are going to be below, and you can click on them and explore. This is hosted publicly for everyone to investigate. One of the things that we looked into with the Wi-Fi program was how do we know what success is and how much do we need and what should we be buying. So the FCC's high-level guidance was $150 per student, but there was no other requirements. You know, a district could have gone off and bought $1 million firewall and not bought a single access point. Well, that wouldn't have made sense, right? So what we tried to do was come up with a realistic approach to quantifying what the need was, and we came up with this idea of access points per classroom, and realizing that we were going to one-to-one, and realizing that the limiting factor on most access points at the time, and even today somewhat, is not so much the total throughput, but the number of simultaneous clients. And based on that, we arrived at the idea that that and the fact that many schools have cinder block walls and the signal doesn't travel far through cinder blocks. So for the best experience, we figured we would put an access point in every classroom, or reasonably close to that. There might be some small classrooms where that doesn't make sense. But then we also said, well, there's places like the gym and the cafeteria, maybe when there's study hall or events, and there's offices and all these other places that we need to also provide. So we came up with a goal of 1.2 access points per classroom. We could not find the number of square feet in a building. We couldn't really find the building materials of all the schools, but we could pretty much figure out the number of classrooms, and we would get that from both the DLMI, and we could interpolate that based on the number of teachers. So we had a pretty good feeling for what the number of classrooms was. So we used that as the x-axis and the baseline for our 1.2 APs per classroom target. And what we've done here is put every school in the state from 2017 onto this chart where X is the number of classrooms and Y is the number of wireless access points. And we've got trend lines, and they're broken out by middle, elementary, and high school. If we want, we can just go in here and say, let's just look at only the high schools. Let's look at only no charter schools, no exceptional children, and alternative education. So just regular, larger building high schools. And you can see this is every high school in the state, and the wireless access points per classroom ratio. And so that is a fairly large school, 1,975 students, 134 classrooms, and 224 access points. So they are 1.67 APs per classroom. And the inverse of that is the number of students per AP. So that's another statistic we'll look at in a minute. But you can see there's a trend line, and schools that are above it have a little bit more access points per classroom than schools below it. This would be considered probably an outlier, and that's interesting. That's Broughton High School, so I am not sure why that happened. Maybe we caught them right before they were getting ready to refresh their Wi-Fi. Down here, these smaller schools seem to be really bunched together, which would to indicate to me that 1.2 number probably was pretty right for most schools. I think when we get up here to these larger schools, the construction and the layout probably has a lot more to do with how many access points they need. And so I think there's probably a few more variables that are in play there. I think the next chart is the same chart, but with access points that are less than 5 years old. So again, I'm going to go back to just high schools and take off the charters. And you can see, we have a school here that's Broughton again. So they had 0. So clearly, yes, they had all their access points were 5 years old. So they were on the verge of getting ready to do a refresh, and that explains why they were an outlier down there. It's nice to see though that there's quite a few schools here that are above the line, and that means that they had participated, and this is the 3rd year of the Wi-Fi expansion. So they had probably upgraded some of them, some of the access points because of the Wi-Fi expansion program, and maybe kept some of their older devices around. Another way you can filter the data is to pick, the student size, or pick the number of classrooms. Say you only want schools that have between 80 and 100 classrooms. You can even go right in here and type 80 and 100. Let's say you're just in that range. And there is some variability, but there's a lot right in the 1.2 range. So kind of feel safe that that's a acceptable target. We also have a way to compare 2 districts. So you can pick multiple districts. I've got only 2 on here right now. We can pick a 3rd. So these are 2 massive districts, and Ash is pretty small. So we can put that on the chart, and Ash is the lighter green color here. It's a little bit hard to see on this screen, but again, this same data is number of classrooms versus number of APs less than 5 years old. Just a different way to look at a couple of districts at once and compare for what they have. If you know of a district that has a certain teaching methodology, use of online resources, then you might want to look at just that district instead of the whole state. The other way we looked at it was by the manufacturer of the devices, or the predominant manufacturer. So we have to be realistic that while a district might be on Cisco today, they might have had Aerohive, but if the predominant manufacturer was Cisco, then they'd be on here as an X. So this is still the almost ratio of classrooms to access points. This is the other way of looking at it, is students to access points. So I think we determined that around 11 students per access point worked out to be about 1.2 access points per classroom. So there's obviously a correlation in the number of students and the number of classrooms. Law of large numbers across the state with 2,600 schools, you're going to come up with a reasonable number when you do an average like that. So here we're looking at 6 districts on one chart, and here we were trying to see if there was any correlation or lack of correlation between manufacturers and density. And I will say that Xeris is a little bit lower. They're the yellow ones. There's not many of them, and they were kind of known for having these large access points that had multiple radios in them. So there is a chance that they maybe actually used fewer devices. It's not that they were cheaper. It's just that they had a slightly different architecture than the other manufacturers. And so we use this graph to kind of investigate that, see if there was anything we should be concerned about with one vendor or the other. Because remember, this was 2017. We were trying to make sure the direction we were headed was for success. This is another chart of, again, halfway through the program. We were third year out of a 5-year program, trying to identify the schools that had not used all of their E-rate funding that was available. And this was used to talk to those districts specifically and say, hey, you have this money available, and even down to the point that we knew exactly how many dollars it was, and that they should probably go figure out how to utilize that. So the yellow are the people that used all of their money. So I'm just picking one here. They have $33 remaining at that school. So I would say they really tuned that one in to use every dollar they could. Surrey County schools, they used 14% remaining. Not bad. And then again, they still had 2 more years to figure out if they wanted to use that remaining $12,000 at that school. Now, this is interesting because this year, starting in 2021, the budgets will be on a per district basis instead of a per school basis. So this chart may not be as useful. It will still be useful. It may not be used the same way. So today, if you have a school with 100 kids and a school with 1,000 kids, you get 10 times as much money for the school with 1,000 kids. In the future, the money is spread out to the district to use as they see fit. So one of the areas we will be checking on is to make sure that we don't see any disparities in the way the money is spent. So we don't expect it to be exactly even, because there are lots of reasons. For example, high schools just generally have way more devices in them than elementary schools. And the high school devices are used more hours per day than in the elementary school. So there are legitimate reasons why you would expect to see some variance in the amount of spending for Wi-Fi equipment, but we wouldn't necessarily expect to see one school get a whole huge amount of money, like $300 per student, and another school get $50 per student. So we'll be doing analysis on that at the per school level to make sure that we're distributing things fairly still. I think that will be an interesting chart in 2022, honestly. That's a new change in the E-rate rules, and it will be interesting. this is the histogram of the APs to classrooms. So each dot or line in each graph is a school that's in that bucket. So on the x-axis is APs per classroom, our regular ratio, which we said 1.2 was the target. And as you can see, there's a huge cluster between 1 and 1.4, which makes sense. There's a nice bell curve here. And each school is on this chart somewhere, along with their information, number of APs, and the amount of money they have remaining. There's some outliers, what happened here. There's a college prep leadership academy. Okay, that's a small charter school. So we don't know exactly what happened there. These are probably some new schools. Sometimes we end up seeing schools that were under construction, things like that. These could be data errors. I would say somebody out here in the 3 APs per classroom range, is possible that they installed their new access points and didn't take down their old ones because they thought that might work better or something like that, or they just didn't count them correctly for the purposes of the DLMI. So that would be a concern. But as you can see, most of the state is in a reasonable range. The 0.6 to 2 range, given we were in the third year. And then this is the histogram of using only new AP. So we're saying access points that were less than 5 years old. There's a whole long list of schools over here that had no access points that were less than 5 years old. Well, they were probably the ones that were getting ready to apply in 2018. And so we expect on a rolling basis, every 5 years generally, for the access points to be replaced or refreshed, just from a technology being outdated. So honestly, that's about 500 schools per year we would expect to see doing a refresh across the state. And then we have a little bit of data on funding in this dashboard that was remaining, because again, the goal here was to identify the districts that had the greatest need and the most money, and make sure that we were utilizing the FCC program to its maximum percentage. So a large box here meant that they had a large amount of money available, and a red box means that they had a low ratio of access points per classroom. So a large red box got a lot of attention because that meant that they had money and they had need. Contrast that with a smaller dark box, that meant that they had money left over and they had a good ratio. So here this Rowan had 2 AP per classroom ratio and still had 39% of their budget remaining. So another one would be Columbus. They had 2% of their budget remaining and 2.2 access points per classroom. So that's indicative of having spent the money on access points. There's other things you would spend your money on, though. You might need cabling and switching and things. This is the same kind of similar graph, but with some bubbles that is on a percentage basis. And then here is the histogram of schools by budget remaining. So the schools over here in this list of 900, all of these are in the less than 10% budget remaining. And then by color code is the number of access points per classroom. So what that means is a green school over here, they used all of their money and they have a good ratio of access points to classrooms. This up here would be a little bit more concerning. That means that they have low ratio of access points to classroom, but they don't have any money left. So those probably got some scrutiny, and we tried to figure out what happened. Then across the a board, there's just schools that spent half their money, and they had varying levels of success, and they still had time left. So the folks down here that had money left and were yellow, we were less worried about. It's the ones that got over here that had very little money left that were still yellow that we had concerns about. Now, keep in mind that we know small schools, for example, had a hard time. If you only had 200 kids, you had a very hard time doing everything you needed to do with only $150 per student. So unfortunately, networks do not grow linearly. There's a step function. Every time you buy a switch, that's like a couple $1,000s, and you can't just buy half a switch. You have to buy things in quantities of number of ports that are available to you, which is usually 24 or something like that. So there were definitely some corner cases, and that is one of the reasons that the FCC moved to the per district budget instead of the per school budget for the next 5 years, because of many cases of what I just explained there, with the one size being not one size does not fit for every school. Up here on the right, we have the schools that have 100% of their budget remaining, and ironically, there are some schools that had all of their budget remaining, but had good coverage. So they may have been just upgraded right before the E-rate modernization, things like that. So there's reasons to explain that. But again, we would look into all these. And then here's our list of schools that were the high value targets, because they had a lot of money and a lot of needs. So those were the easy ones to figure out that they needed to go apply for the E-rate the next year. And then the next chart is interesting. This is not anything to do with Wi-Fi. It is to do with the connection from the school building to the center point of the district. So the internet for each district comes to a single point, usually at the high school in a small district, or at the district headquarters in a larger district, or sometimes just some random other building that happens to be cost effective to use as the center point for the district. And what we've done here is we've shown every school in the state. On the x-axis is the connection that leaves the side of the school building out into the fiber down the road. And on the y-axis is the number of students in the school. So what you're seeing here is this 1,000 is the gigabit connection for the schools. So these schools all had a 1,000 megabit, 1 gigabit connection to the internet. And it's also color coded by rural and urban. So the blues are urban and brown's rural. And that's based on the FCC's definition of rural and urban, which we don't always all agree with, but that's what the rules are, so we have to go by that. But when you click on each school, you can see the number of students and what grades. Does it have a bring your own device strategy or device issued to the students, and the ratio of access points per student, students per access point, and APs per classroom. And it's interesting to see what the connection speeds are. Some oddballs. Back in 2017, we had, here this was Durham, I think, and what was it? Transylvania. 300 megabits is non-standard internet speed nowadays, but back then that was not uncommon. A fraction of a gigabit was not uncommon. Today, if we redid this chart, a lot of these intermediate speeds would just be completely gone, and everybody would be on either gig or 10 gig, and maybe some in the 2 and 4 range. But usually the cost of going from 1 gig to 10 gig now is such that there's no reason to stop in between from most service providers. And some of these connections down here at these much lower speeds are all probably gone. I'd be surprised if there was many down there in the sub 100 range. So this is an interesting way to investigate, the circuit speed leaving the building. So let's go ahead and do just regular schools, and even let's just say just urban. Okay. that's interesting to look at. There's a school here. So when you have 2,000 kids almost and only 150, that was a school, New Hanover Press, that was a school that would be ripe for getting a bandwidth upgrade. Let's see, when we get to, here's another interesting case though, right? Here's a 10 gig connection to a school that only has 245 students. So you have to question what happened here. More than likely, it was a district-wide contract that all schools got 10 gig fiber, and that was the most cost-effective solution. Even though they might not have needed it, it was the cheapest way to get everybody that needed 10 gig to get 10 gig. And so that is one of the things that's probably the topic of a whole nother set of research, and that brings us to the topic of overbuilding existing service providers using universal service fund. Not an exciting topic for many people, but there were a few people at the FCC that definitely would love to hear more about that, and I have a lot to say about that, but we have to get a little bit more data in before we'll have some conclusive results. So stay tuned for another video, probably after the E-rate window closes for 2021. And then finally, I think this is one of the most interesting charts, and this is a ratio of the district-wide average internet utilization versus the number of wireless access points. So if you go back to the first video in this series of 3 videos here from November 2020, we started talking about average utilization and contracted bandwidth on the NCREN, North Carolina Research and Education Network. And so here we're going to close it out with our last chart, brings us all the way back to that and looks at the ratio of wireless access points to utilization. And you would expect that the more access points you have, the more utilization you have. Now we've scrunched this graph down a little bit to not show Wake and Charlotte. So just real quick, I will pull in Wake and Charlotte. And the reason we do that is because they make everybody else kind of disappear, and it's harder to investigate the data. So we're taking them off for a second and going to just the districts besides them. And we're color-coded by the amount of funding remaining, and only looking at regular schools. And we see that most districts are right here, like they're right on the trend line. There's Rowan again, right on the trend line. So based on the number of access points we are seeing in the utilization as measured at MCNC on the backbone, they're right in line with what we would expect. I think that this is surprising that Mooresville, which was a leader in one of the first to go, I think, 1-to-1 in the state, is actually somewhat lower on their utilization. They're actually somewhat lower on their number of access points than you would expect. So that being yellow, though, indicates that they've spent a lot of their money. So, but we didn't have anyone complaining that they weren't doing digital learning correctly at Mooresville. So that's an interesting, data point, I think. Alamance, again, I always like to use Alamance. That's just right in the middle of the state and just perfectly usually in line with what we would expect. There they are, right on the trend line. So you can see the average student usage. This is 2017 again, 96 kilobits per student. And then the number of the aggregate WAN capacity is 52 gigabits. So the 96 kilobits is measured at the internet connection. And so you would take 96.9 kilobits times 23,247 kids, and that would be the aggregate capacity of the internet connection average at that school district. And that happens to be 2.253 gigabits or 2253 megabits. So that's how you would read that. Forsyth and Cumberland, right around the same ratio. I think the outlier here, Guilford, this would indicate, based on having that many access points, we would really expect to see them way higher up the usage curve. So that kind of is an indicator that they might need to buy more devices. They have plenty of access points, but they do not have that much utilization. So if we pull the chart all the way out, we can see, Guilford to be on the trend line would be out here at almost twice the utilization that it was at in 2017. I do think this is interesting, that the discrepancy between Charlotte and Wake, but we have to remember Charlotte in 2017, I believe, was the largest Chromebook deployment in the world, and I think they had around 100,000 Chromebooks deployed in the district. So they weren't, I think, one-to-one in every grade, but they were one-to-one in a lot of grades, and so they would have been higher than normal. And it's interesting that they also had quite a bit of budget remaining in 2017. That probably comes from the fact that they were a high E-rate discount district and a large high-rate district. And prior to the rule modernization in 2015, those were exactly the districts that ended up getting the priority in the Wi-Fi funding from the FCC. And it was actually quite unfair, to be honest. So they changed the rules and gave everybody $150 per student, and it was to kind of level out across the entire country instead of focusing on just the really high E-rate discount school districts. So that's pretty much a detailed look at some of the data that we've looked at over the years to help DPI and the state board figure out how to manage school connectivity. I hope you enjoyed it, and we'll probably come back with some more videos and dashboards in a couple months. Thanks.